You're about to fall into a black hole. From your perspective, you've got maybe 10 seconds before everything ends. But to anyone watching from outside, a space station, anywhere, you never finish falling. It takes forever. You cross the event horizon, and they watch you freeze in time, trapped at the edge, burning red shifted into nothing, in slow motion, forever. Except you don't feel any of that. You feel something way worse. 10 seconds for you, infinity for them. Two completely different realities, happening to the same person, at the same time. It all comes down to 3 questions, and you're not going to like the answers. 1. What's actually happening to you in those 10 seconds? 2. Why would you end up begging for it to be over? 3. And when it finally comes, how? So, let's do this. Imagine you are in a spacecraft, moving at orbital velocity, and you've got a clear shot at a black hole about 10 times the mass of our sun. Don't ask me why you're doing this. Maybe you're a physicist. Maybe you lost a bet. Point is, you're committed. You cut the engines about 1,000,000 kilometers out, coasting. The black hole itself is a point about the size of a city, a singularity, but the gravity well around it spreads out for hundreds of thousands of miles. You're passing the orbit of Mercury right now, relative to the black hole's center, and everything still looks fine. The view out the window is almost peaceful. But then, your instruments start screaming. The gravity gradient, that is, the difference in pull between your head and your feet, is now measurable. It's not huge yet, but it's real. Your feet, which are now closer to the black hole, are being pulled by a force about 0.001% stronger than your head. Doesn't sound like much yet. But your body is made of meat and water, not titanium. The cells in your feet, the molecules, the atoms themselves, they're all being stretched. Your spine feels tight. It won't feel painful yet, just tight, like you've been lifting too long at the gym. Except, it won't stop, won't decrease, won't ever ease. You try to turn around, but the ship's computer isn't responding the way it should. There's a lag. The closer objects get to extreme gravity, the slower light itself can escape. Signals take longer. Communication back to Earth, if you bothered to send a message, would take hours just to arrive. Then hours more for a response. By then, you'll be somewhere else, somewhere closer. Closer to what exactly? Let's say you got lucky, and somehow you managed to still be alive. Then you fire your engines in reverse, full thrust. The ship shudders. The acceleration readout on your ship says you're pushing 40 Gs. Your organs should be turning to paste by now, except they're not, because the black hole's gravity is also pulling you with 40 Gs. Right now, you're in equilibrium. You're weightless, comfortable even. That's the weird part. Right now, you can't feel anything wrong. But your instruments don't lie. The tidal forces are doubling as you fall deeper. Your feet now experience twice the gravity of your head, not twice like Earth, twice like falling off a building times infinity. The blood in your legs wants to drain toward your feet. The tissue compresses, hardens, turns dark. Capillaries burst. Your skin starts to split from the inside. You're not panicking yet though. You should be, but you're not. The pain is so extreme, so complete, that your nervous system just stops reporting it. Your brain gets flooded with endorphins, morphine-like chemicals your body produces as a last-ditch effort to keep you conscious. You're the deadest you'll ever be while still being alive. And here's the kicker, it's only going to get worse. You're still 100,000 kilometers out. You're only 1/10 of the way to where things get genuinely catastrophic. But this is where it gets weird. Let me rewind. You're not the only one experiencing this. There's an observer on a space station a safe distance away, watching you fall into the black hole in real time. Except they're not watching you fall. From their perspective, from anywhere outside the black hole's event horizon, they watch you slow down. Asymptotically, that's the math term for approaching something, but never quite reaching it. Your spacecraft, moving faster and faster as you fall, appears to slow as you approach the edge. Your image redshifts, the light stretches out, turns red, then infrared, then disappears entirely. To them, you're frozen, still in a single location. Feel it. You're forever at the moment, just before crossing the point of no return. They could watch for 1 billion years and see you in the exact same position, fading, fading, fading into blackness. You never complete the fall, not from their perspective, but you, the you that's falling, the version of you that's actually experiencing this, you're living through it in real time. There's no slowing down from your frame of reference. Time, for you, moves normally. 10 seconds, that's all you've got left. You're in 2 realities simultaneously. 2 different truths about what's happening to the same person. Physics allows both to be real. Now, back to your own descent. The tidal forces have tripled again, then tripled again. Now you're closer, close enough that the visible event horizon, the edge of black, the point of no return, fills half your view screen. It's perfectly black, not dark, not shadowy, black, an absence, a hole in reality. By this time, your legs are gone, not in the sense that they're detached, they're still attached, but the tissue has been so thoroughly shredded, so completely separated into individual components, that there's no meaningful difference between your leg and the matter around it. You're decomposing at a molecular level while alive. The pain is beyond pain now. Right now, I'm feeling for you. It's sensation itself, pure and raw, with no context, no memory of anything else, just the present moment, eternally. Your ship has been crushed. It's thin now, flattened like a pancake, perpendicular to the gravity gradient, not by compression, by differential forces pulling everything apart. The material is stressed beyond its tensile strength. It's failing. And then, you cross the event horizon. The moment you cross, everything changes. This is not because anything physically different happens, the tidal forces continue their work, but because information stops existing outside your frame of reference. You're beyond the edge. No signal, no light, no gravitational wave from your destruction can reach Earth. You're thermodynamically inaccessible. Dead information, erased. From your perspective, you keep falling. 50 kilometers, 10 kilometers, 1 kilometer. The singularity emerges in your view screen, except it's not a thing you see. It's the absence of space and time. It's what happens when physics stops working. At the singularity, density becomes infinite, gravity becomes infinite. The equations that describe the universe just break. They hit a wall and return an error, unknown. Then you hit it. The end of an existence. This answers our questions. 1. What's actually happening to you in those 10 seconds? 2. Why would you end up begging for it to be over? 3. And when it finally comes, how? Now, here's the part that actually happened. We've never directly observed a black hole until 2019. The Event Horizon Telescope captured the first image of Messier 87's black hole, a monster with 6.5 billion times the sun's mass. The image showed the shadow exactly where Einstein's equations predicted it would be, down to the decimal point. We know tidal forces work this way because we've measured them around neutron stars. Neutron stars are what's left after massive stars die. They're so dense that a teaspoon of material would weigh as much as Mount Everest. Astronauts in orbit around them would be shredded by tidal stress. We know this mathematically, we know it. The time dilation we described, the observer watching you freeze at the edge while you experience normal time. We've confirmed this at a smaller scale. Atomic clocks on the International Space Station run measurably slower than clocks on Earth. Not by much, by microseconds, but measurably. So here's the question that keeps physicists awake at night. If information about you, every atom, every qubit of data that makes you you, falls into a black hole and can never escape, where does it go? Stephen Hawking proved that black holes actually evaporate, releasing radiation. But that radiation is random. It doesn't contain the information about what fell in, so the universe has a garbage disposal. Everything that falls in is erased permanently, except that violates a fundamental law of physics, information conservation. The universe isn't allowed to erase data. Nobody knows which law breaks. Maybe black holes aren't black. Maybe there's something that catches the information at the edge. Maybe we're completely wrong about what happens at the singularity. We'll probably never know from inside a black hole. This is Mr. Universe. Do subscribe to my channel.